right, we're going into review mode again to look at, if you look at this, this sheet was actually pulled from a workbook you guys had that I probably used back in October, maybe. And what I want you to look at is all it's asking is for the slope, which is super easy. We know that slope from review is either rise and run, or it could be fall and run. And you know, I always put fall and run with the negative sign because it's a negative slope. If you look at 1 and 2, which one would be negative? Obviously 1. And then when you try to find the slope, I need you to find points on there. So I'm going to make mine a little bigger here, and then I'm going to go ahead and find all these points right there. So all these points could be used to find your slope. You just need to pick 2 of them. And if we go back and remember, if I was to go ahead and do fall here, I'm going to fall 1, 2, run 1. So that would be -2 over 1. If I kept doing that, that would be the same pattern, right? Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Well, what if I chose to go down 4 over 2? Well, down 4 over 2 still gets me, when you reduce it, it's going to be -2. Okay. So your slope here, you would just say -2. All right, let's look at number 2. We know it's a positive slope, but I can see a coordinate right here in the middle. That's a coordinate. How about I keep following this up here? Is that a coordinate? That's a point too. Cool. Now let's go ahead and do this. Up 1, 2, 3, 4. Up 4. Over 1, 2, 3. Over 3. Up 4 over 3. So the slope would be 4 over 3. Okay. Again, just getting you reviewing. And notice both these lines, where is their y-intercept at? Right in the middle at 0. So if I really was to write this equation out, it would be y equals -2x plus 0. But do I really need to put plus 0? And then for this one, it would be y equals 4 over 3x plus 0. Wouldn't have to put plus 0 there, because again, this is called proportional. If you remember from 7th grade, when the line goes through the origin, it's called proportional. And you should remember that, because we're going to go into non-proportional in a second. All right, so now we're looking at graphs that are a little different here. Now you don't have a line. You have to just look at the equation. So if we're looking at this here, what would be your first step to graphing this equation? And I'm hoping you remember this. I don't think I needed to do a flow map on how to solve this. The first step, plot the y-intercept. Plot the y-intercept. Well, it's called the y-intercept because you're supposed to plot it on the y-axis. And where's your y-axis? Okay, it even tells you. You see the y right there on the top of your graph. This is your y-axis. So we're going to plot a point on both of these. I'm actually going to do both at the same time here. So -1 is my y-intercept. And that's what you also have to remember. It's always at the end. Whatever's next to the x is the slope. X is not part of the slope, okay? So if we were to write this down, this would be a great visual for you guys. Y equals something x and something. And we went over this when we did scatter plots 2 weeks ago. So the slope is here, and this is the y-intercept. And you guys know this. Again, I'm just making sure we're just refreshing today. We know what will happen is. So the first step would be plotting the -1. So my -1 is going to go here. Let me make this just a little bigger now. All right. Then my slope, okay, over here, plotting the 3. 1, 2, 3. All right there. So that's my y-intercept. So you can actually put that right there, -1 and 3. What's the slope? Well, this one has up 2 over 1, rise 1, rise 2, run 1. And if you wanted to make a super straight line, you could keep going with the pattern. Rise 2, run 1, rise 2, run 1. You can't do this anymore over here. Now, what's the opposite of rising 2 and running 1? You could go down 2 to the left 1, down 2 to the left 1. All right. And then I'm going to get fancy, and I have my ruler here. And if I wanted to, it's not perfect. Let's try to be perfect as much as we can. You have a ruler here. Come on, Mercy. And there's my line. Okay. So it's a positive slope. So it is a positive slope, but I'm actually going to put the number, and that's what the slope is, 2. So if you have a slope of 2 and a y-intercept of -1, your equation looks like that. Y equals 2x minus 1. All right? High school is going to make sure you understand this. You must know this for high school. You cannot go into there going, oh, I don't remember. No, you have to know this stuff, okay? So 3, positive 3. Then what's my slope? Is it positive or negative? Well, it's a positive number. Am I going to rise or fall? I'm going to rise 1 and run 2. Rise 1, run 2, rise 1, run 2. If I'm rising 1 and running 2, can I fall 1, go to the left 2? Fall 1, go to the left 2. Fall 1, go to the left 2. Okay? Same idea. I can do both of those. All right. So then I'm going to go ahead and put this here. And then draw my line perfectly through it. All right. So those are your 2 slope-intercept form lines that we drew. Let's see if we can kick it up a notch and do even more with this to see if you can handle it. Okay, so if I'm looking at this and it says, determine if the relationship is proportional or non-proportional situation. Explain your reasoning. Assume that the tables represent linear equations. So that the tables are in the other problems. We're only just doing this first 2. Okay, so we're not worried about the tables here. But we are going to look at these 2 graphs. So when I look at this first graph, I'm actually going to take it one step further. Instead of you just telling me if they're proportional or non-proportional, you got to actually solve and give me the actual equation. How do I want to see the equation? Y equals slope x plus y-intercept, okay? And how do we know if something's proportional? Remember, we've done circle maps with proportional. And it's actually a good idea to bring that back possibly. We might do that later in the week. Proportional, we just talked about it earlier. It means it goes through the origin. Which of these 2 lines goes through the origin? It's pretty easy to see, right? So for proportional, you got to make sure you see this here. It's a proportional relationship, and it also has to be linear. And linear just means line. Maybe in Spanish it's línea. It's a perfectly straight line, right? So that's a perfectly straight line, and this would be proportional. This one is non-proportional. Oops, let's go back there. This one's non-proportional because it does not go through the origin, but it's still linear. It's still a perfectly straight line. Okay, so let's go to attack number 1 now and see, first of all, where does it cross the y-intercept? I mean, yeah, where does it touch the y? So y equals, and I would say it's plus 3. We're good there? And then where do you see another point? Is that a point? No. Is that a point? No. No. Yes. And there's your point. If you kept going again, the same pattern, there's your other point. So what are we doing? Are we rising 1 and running 4? Rising 1, running 4. If we kept going to the pattern, it'd be doing the same thing. How would you write that? Rise 1, run 4. And there is your slope-intercept form of the linear equation. It might be very important to understand which form you're using. Well, for us, we've only used slope-intercept form. Why do they call it slope-intercept form? Pretty cool name, right? You're like, cool, Mercy, come on. But why would you call it slope-intercept? Slope-intercept form. Okay. All right, I'm going to erase everything just real quick. And now let's look at number 2. Where are you going to put your first point? It's going to be at the origin. So let's go ahead and find another point here. Is that one right there? Kind of looks like one right there. Yeah, we're good. Oh, actually, no. You know what? The pattern doesn't seem consistent, does it? Because I went up 1 over 3 thinking that was a coordinate, up 1 over 3, up 1 over 3, but that did not work. So that isn't consistent. Let's see. I'm really wondering if this actual problem, I mean, maybe that's a coordinate. We'll just call that one the coordinate. And we're going to say it's up to, well, actually, no, guess what? If we call that the coordinate, this is interesting. It would be up 2 over 6. What does 2 over 6 reduce to? Up 1 over 3. Okay. So you know what? We're just going to call it 1/3. We're gonna move on from there. Y equals 1 over 3x. What's the y-intercept? Plus 0. Do we have to write plus 0? Nope. And that would be good enough right there. That would be perfect. Okay. So you can handle it that way. All right, we're going to kick it up a notch. Write an equation in the form of y equals mx plus b for each situation, okay? The easier one to look at, I would say, is the graph. You'd be like, okay, I can do this one from the graph. We're going to do the graph quickly, and then we're going to go over what a table looks like. And if you remember, and this is kind of the extra, this is going to be the level up to this week, okay? You got to make sure you're good at this, leveling up and knowing how to put this into an equation, all right? But for this one, it's not too tough. We see that's at 0. And then we're going to rise 20 over 1. Rise 20 over 1. That's the pattern. How would you write that as an equation? Would you put plus 0? You don't need to. It's pretty redundant, which means not really needed. All right? So that's your answer for that. Now, let's go ahead and attack this one over here. So if we're going to attack this one, I'm actually going to delete everything real quick. I'm going to go back to this problem again. And when we look at this, there's one very important rule you have to do first. All right? And that's going to give you your slope. Okay? If I put everything over here, y equals something to x and something, we got to figure out the slope for this one first. When we do that, we can go ahead and look at these, any 2 points you want. If we do, and this is x, oh, this is interesting. I did it backwards for you. Okay, so if you look at this table, it's kind of messed up. Usually we do x, y, but look how it's labeled. They actually did tell you this is y and this is x. So this is kind of a goofy one, but we can still get through this. I don't want you quitting just because you haven't seen something before or you're not familiar with it. You have to learn in this life that you have to attack things. Even when you're not fully have ever seen it completely, you can still attack it with what you've known and what you've been taught. Okay. Now, if I do 360 minus 300, I'm doing this right here, and that's y minus y. I'm going to go and get 60. And what if I do 0 minus 10? I'm doing x minus x. 0 minus 10? Well, nothing from negative 10 is just going to be negative 10. And when you look at this and you were to plug it in the calculator, you could reduce it. 10 goes into 66 times, and that negative's there. So negative 6. Okay? Which is great. It's perfect. We need all that information. Actually, don't really know that. So how do we find our y-intercept? We did this with the scatter plot lessons, if you were paying attention for those. Pick any point you want. And guess what? I'm going to get real easy. I'm going to put that 0. So this point's actually 0, 360. The way we're used to looking at it, x, y, this actually should be in reverse. And where would I put the 0? Where the x is. And where would I put the y? Oops, go back. It would put it right, come on, where's it? Right here, where the y is. It's being finicky here. So 360 equals 0. Is that true? It's negative 6 times 0. Does 360 equal 0? How do I make it 360 equal 360? Would I just go ahead and add 360? I would. And that's the way I would handle this. You're going to do stuff like this on your quizzes tomorrow, okay? If you want to do the quizzes now, that's fine. Hey, guys, you should get the work done, all right? Find time to get your work done, please. This is very important for you to get ready for high school, and I have to make recommendations. And if you're not giving me any work right now, those recommendations are not going to look great for your math teachers, all right? So do the best you can. Do all the work. Every time it's labeled throughout the whole week, it gives you everything each day of what you got to get done, all right? Best of luck, guys. Give me a holler if you need any help.